Good evening. You probably thought from my name that I would sound like Kirsty Wark. Well, maybe I do a bit. At least it's not like Malcolm Rifkind, I hope, but, or the late Robin Cook. I'm going to talk about a range of subjects. I'm probably going to end up leaving you with some questions rather than answers, but that's basically the structure of the talk for this evening. So, if I get this right, I'm going to have a look at our evolutionary past first. For millions of years, there have been living creatures on Earth, and they've been multicellular for at least 1,000 million years. And we separated from the great apes roughly 5 million years ago. And we, as we know ourselves, have been around for roughly 1 million years. But it's only in the last 50 years we've had fast food and gasoline and central heating. And so our physiological systems are having to cope with a massive change. And that's the essence of the problem, really. Now, as creatures became bigger, as they evolved into larger animals, they needed to communicate with each other internally. They needed to communicate internally. They had to develop organs with specific function, and they had to integrate these functions. This led to the emergence of nervous systems and hormonal systems. Now, this is an MRI scan of the brain. That's the sagittal section, that's the coronal section. Now, you can see how nice MRI is these days. You can get very nice definition of soft tissue. Now, you can see how folded our cerebral cortex is compressed into our brain, especially at the front. And this white strip across the middle is the corpus callosum, which connects the left and right side of the brain. But what I'm interested in talking to you about tonight is the lower bit of the brain. The lower bit of the brain is the brainstem, the hypothalamus, and the pituitary gland. And these are in this region here. And you can see the spinal cord coming up. Is that me? No, sorry. Oh, sorry. And you can see that the brain starting to thicken out there. So this is the area we're going to talk about today. Now, oops. Sorry. How do I go back? Yeah, there we go. These lower bits of the brain are very ancient, and they control all the things we probably, for the most of the time, don't think about. Our appetite, our growth, our temperature, our blood pressure, our sleep-wake cycles, our stress responses, water balance, and reproductive function. That's why if you're in a really bad road smash and half of your head is lost, you can live for years without being very aware of it, because this bit is very old and functions on its own with input from all other places. So you get hormonal and nervous interactions with the body into this sort of lower bit of your head. For example, in an evolutionary sense, your visual cortex would see a large object moving. The message would come across your brain to your temporal cortex and say, that's a bear. And the amygdala, which is coming round to about here, would say, this is very scary. And so all of these things would be sort of happening at the same time. This amygdala would have sent massive signals down to the lower half of your brain and say, stop feeling hungry, sexy, sleepy, get your heart pumping, dilate your pupils in order to see better, breathe deeply so you're getting plenty of oxygen into your brain. So this system is hugely important in our sort of our functioning, and for integrating signals coming down from the brain and integrating signals coming up from our peripheral organs. Now here's the good and the bad news. For about 1 million years, we spent a lot of time wandering around, looking for food, eating berries, and so on, threw stones at rabbits, tried to stab fish with sharp sticks. And a lot of our wake time was probably spent looking for something to eat. So we developed biological systems that enabled us to be energetic, to store energy, to survive cold, and to survive famine. The bad news, what we've got in place has arisen from our evolutionary past. And in fact, if you're overweight at this point in time, it may be that you've got good genes because you survived. You had good survival genes. But this is the problem. This is in conflict with our evolutionary past and where we're at now in the 21st century. So, this is what we're having to deal with. That. Start early. Start early to be conscious of your shape. Cook more. Diet more. So, we're being assaulted and sort of told to think about our appetite and our shape all the time now, and we're very unadjusted in an evolutionary sense for this environment. Now, I've got a little bit of biology in the middle here, and it's quite straightforward. Just don't panic if you see some odd words. It's important to understand from the beginning that we're actually quite good at regulating our weight. If you think about what happens in our daily life, we probably eat several tons of food over a 10-year period, and our weight may be going up by 20 pounds. So we've got quite a good system in place. And there's a sort of slightly nebulous concept that biologists use. They think of us having a set point, but there isn't a definite biological correlate of this set point that we have. But we obviously can regulate ourselves quite well, and I'll come to that again. Now, contrary to what you might think, your daily food intake varies quite a lot. Your energy intake varies on average by about 25%. You sort of eat a lot one day, and you eat a bit less the next day, and it just goes up and down. And what you probably, again, don't realize is that your energy expenditure doesn't change very much. Even if you go out and run one day or go to the gym one day, most of the energy that you use is to keep yourself warm and to keep your body metabolically intact and the organs functioning. I should just mention in that context, sometimes people, when they're heavy, they will say, oh, I've got a low metabolic rate, or I don't use much energy. Obviously, I'm very efficient. The general consensus of opinion is that that is not true. You have to see us more in terms of big cars and small cars. And if you're a big car, then you use a lot of gasoline. So we're not actually designed to be that different in terms of how fuel efficient we are. What I was saying is that energy intake should be more easy to control. It actually, as we all know, is not the case. Now, just a little biology. The only reason I'm putting that picture up there is just to remind you, of course, that you take food in, it goes into your stomach, then it goes through your intestine, and you put out the waste. The important thing about it is that it's a hugely controlled system. It's really a very, very effective system. It's got hormonal connections that go to the brain, and it's got nervous connections. It's a very well-controlled process. The other thing maybe worth mentioning in a published lecture is that when people talk about detoxing I think that's rubbish. Your gut is very toxic. Your gut is very toxic. It's full of bacteria, and they're meant to be there. And if you don't have them there, when you're young, your immune system doesn't develop well, and there's a whole lot of other roles they have. But detoxing is probably a sort of, somebody working in this field, is a slightly off-the-wall concept. Now, the sort of physiological signals that control eating behavior. Obviously you get visual signals, you get smell, and you get taste. And these are external. And then you've got there are two basic kinds of internal signals that control your eating behavior. There are signals that actually arise from your intestine and your gut and your sort of digestive system. And they're one group. And then there are signals that arise from everywhere else in your body, from your muscles and from your fat stores and from your other organs. So these are all feeding into the brain, either coming down from, as I said, it's visual, or coming up from your gut, or coming up from your muscles and your fat stores. They all go to the lower brain, and they all go to satiety centers and hunger centers in the hypothalamus, which is sort of basically in through there and in through there, sort of very low in the brain. The ones related to the gut are the sort of obvious ones. If you push a pizza into yourself, you feel full in minutes because you distend your gut and you release hormones from your intestine. These things happen before you've actually, they start to happen before you've actually processed anything. It's partly a physical process. And these are of a lot of interest to the pharmaceutical industry. Some of these dietary compounds are there to distend your gut. That's all they do, to provide bulk. Some of them are to stop stuff being absorbed in your intestine. And the ones which stop fat being absorbed do in fact work. Except you can end up with a very oily stool, and you can end up being leaky. And so people don't like taking them. But they will stop fat being absorbed, certainly. The other system that's important is that you get glucose in your blood, insulin in your blood, a hormone called leptin, which I'm going to talk about, and the stress hormone. All of these are in your blood, coming from your tissues, and they go to the brain, they go to the hypothalamus, and they say, he's undernourished, she's overnourished, etc., etc. She needs a meal. Now, you all know that the glucose-insulin axis is faulty in diabetes, but leptin I'm going to mention because it's been in the press a lot. It's quite a topical hormone, if there is such a thing. But now, leptin is a hormone that you have in your fat cells, and you release it from your fat cells. The important thing is you release it in proportion to the amount of fat that you have in your fat cells. So the fatter you get, the more leptin you release. And it goes to the brain, and it controls your fat levels It controls, it is a lipostat. It's a fat sensor. And if you inject it into animals, they will lose weight. It works very well in small animals. And there's huge pharmaceutical industry interest in it as a therapeutic target for obesity. It's altered, and it's altered in anorexia nervosa, for example, but it's not. Its functioning is not abnormal. So this hormone is the sort of fat sensor in your body. But one of its very important roles in women, or mammals in general, females, is it controls reproduction. If your fat levels go too low, your leptin levels go down. And it goes to the hypothalamus and it says, you are too skinny to carry a baby for 9 months, and you will not ovulate. So it's got a very important role in controlling female reproduction. And that's why if you're a road runner who's very muscly with almost no fat, you can get amenorrhea. If you're a ballerina who's just too little body fat, again it would happen. Or if you're a girl with anorexia, the same kind of thing can happen. It's because the leptin goes down. Once you get the leptin back up, the menstrual cycle will come back. Now, let me talk to you about hunger and satiation. As I said, there are centers in your hypothalamus that control hunger and control satiety. And they're enormous interest to the pharmaceutical industry. The problem about them is that there's quite a lot of redundancy in the system. You can knock out part of the system and it still works quite well. And this is what you would expect in an evolutionarily conserved system. If feeding and hunger and satiety are so critical to your being, then it shouldn't just be on one light switch. And so that the system has got huge compensatory mechanisms in it. And that's been the problem for the drug industry in part. It's all, as I said, in about here, it's all controlled, and you've got all these hormones coming from your guts and from your tissues and nerves, and they all go in and say, you've had enough, you've not had enough. And then there's coming down from the top of your brain, seeing things, smelling things, tasting things, thinking about food. So this is this integration. Now, the hunger mechanisms are, as I said, are complex, but they're being worked out, and as I said, by industry largely. Industry's hugely interested in it. It's a big market, the diet industry, as Raj said. But of course, why we eat is a much more complex idea to think about. If you talk to students and ask them, why do you eat? And they say, bored, it's lunchtime, being social, when we're relaxing, etc. And how much do you eat? They'll say, I eat what I'm given. If I'm given 2 potatoes, I'll eat 2 potatoes. If I'm eating 3, I'll eat 3. And hunger, for a lot of us now, is not something that we experience that much. Now, if you're in the business, satiation and satiety are 2 slightly different concepts. Satiation is the process that occurs as you're eating. As you're eating, the food is going in, and gradually you begin to feel full. That's it. Satiety is how long you feel full. So there's sort of 3 or 4 hours between sort of 2 o'clock and 6 o'clock when you're not feeling hungry. That's what people call satiety. As I said, satiation is this initial phase. As you're eating, you say, I've just about had enough. If you eat fast, of course, you bypass satiation. So if you buy a large hamburger and large fries and are walking along the street, you eat them all before any of your biological systems related to satiation have a chance. The same happens if you're engaged in doing something else, driving your car, watching the TV. You tend not to be aware of your satiation mechanisms. Oh, sorry. So, taking your time and being more aware of how much you're eating would help to reduce our input. That's why they say the French are supposedly thinner than we are, because they take more time with their eating. Whether that's true, I don't know. They're probably thinner than the Scots, I can tell you that. We do have deep-fried Mars bars. And I went into a place in Wick last year and said, "Do you have them?" She said, "Do you want it with chips or do you want it with ice cream?" So I thought, that's Scottish cuisine for you, you know, sort of. Am I going backwards? Oh, gosh, sorry. Now, I thought, because this is an area that I work in myself a bit, I thought I'd talk to you just a little en passant about eating disorders, and what we can maybe learn about eating and satiety. When people talk about eating disorders, they talk about restricting anorexia nervosa, which is when people just stop eating. They talk about anorexia nervosa, about binge purging, when people don't stop eating, but they binge and then they purge, and they take laxatives, they go and vomit, and they look. So the anorexia nervosa restricting type and the binge purge type these are thin people. Bulimia nervosa are when people have similar habits, but they're often at normal weight. Binge eating is self-explanatory, but we all binge eat a bit, but of course I'm talking about somebody who, if they open a box of chocolates, will eat every one, or if up at 3 in the morning and not have a slice of cheesecake, they'll have the cheesecake, you know. So, and whether you put obesity into this category is a question, of course, that we can talk about. People, their diagnostic symptoms change. They drift in and out of, sometimes they start as restricting anorectics, they become binge purgers, then so on. And it's a couple of questions to ask. Why do why do they develop? Is there a predisposition? And why does it usually happen in women around puberty? Well, I've got a couple of slides from Jacobi et al. Just a couple of points to mention here. The main risk factors for having anorexia nervosa is being female and doing a lot of exercise as a young girl, but also being of a rather perfectionist nature, having sort of obsessive compulsive disorder symptoms, personality, and having a negative self-esteem. Now, they haven't mentioned genetic factors. Genetic factors are actually very important. It's just they didn't look at them. Now, if I can just get you to compare this. Bulimia is different. In bulimia, usually, again, it's being female, but they think negative self-evaluation, usually a young girl who is maybe a bit plump and goes off on a diet and gets into this it's sort of cycle and gets bulimia nervosa. Okay. Now, these are not clinical pictures. These pictures are on the web. These are not clinical patients of from our hospital. I just mentioned the FMD. They're quite famous. They're called the Kendall twins, and they're both dead. And I put it up because, as you can see, there's a huge genetic bias in anorexia. These are from twin studies, so that women who've got a twin who's anorexia nervosa a much higher chance of getting it. Women are, of course, 9 to 1 more likely to get the problem than men. And the question is, there was a feminist position that would have said that it's because men put all this pressure on women to be shapely. And I don't hear people talking about that much. That comes out and goes as an idea. But it's not a terribly common opinion now. People have a more biological explanation, which is that women are relatively unstable in terms of their weight, and they have to be. You have to have your weight going up through 25 pounds, then have a baby, and go down again, go up and down. You need to have flexibility. And in previous centuries, women probably were pregnant maybe 10 times over 20 years. And so their weight was shooting up and down, and their body had to adapt to this. So their weight regulation biologically has to be more unstable and be able to change. There are massive changes in your hormones if you have anorexia, bulimia, but they're probably not causally involved because they nearly all resolve when people get well. They're a consequence of the illness rather than the cause. This is an article from the Times earlier this year, and it's showing that the incidence of anorexia nervosa is fairly constant, but the incidence of bulimia seems to be much more culturally defined. And the conclusion from that is that AN is probably quite an old disease. You get, and bulimia is more culturally defined. Now, just one last thing about eating disorders before we move on. If you're looking at this spectrum here, are eating disorders on a continuum? Because obese people are not usually seen in a psychiatric setting, obesity can be seen as something quite separate. It can be seen as a normal adaptive process, and it's the long-term consequences of obesity which is the problem. But there is no doubt that obesity has an overlap with binge eating and bulimia. And my colleagues would say that pure restricting anorexia is probably the most different of all of these because it's the one that involves not eating. But this is open to debate. There's lots of interest in higher brain centers now in eating disorders and lots of genetic research on the regulation. But it's unlikely that there's going to be no single gene for obesity. There's going to be no single gene for anorexia. There's going to be no single gene for bulimia. These are polygenic disorders. They've got lots of genes that are involved with small effect. And you do get it in animals, or you get something very near. When they breed animals to be lean, you get skinny ones emerging. And they call it thin sow syndrome, for example, in pigs. And they waste away and become scrawny and don't do well. And here are the ongoing issues. Why do people eat? Why do they overeat? I'm just going to run through 4 slides very quickly and then move on. But you eat, there's genetic input, there's physiological factors, your psychological state, and your environment, your climate, the habits, so on. The only reason I'm mentioning that is it's quite complex. That's all. So it's very hard when people are looking for simple solutions. However, as far as our society is concerned, I think the core issues is food availability and consumption and our lifestyles. And I'll just talk about a little more detail about that. Food has to be rewarding, of course, if we're going to survive. If we didn't think it was a wonderful thing, we wouldn't eat it, and we would waste away. But there's an endless choice. Your food choice is affected by your genes, but obviously it can be altered. So when you're a baby, if your mother gives you glucose, something sweet or something fatty, you'll eat it. If something bitter, which could be toxic, you'll spit it out. You'd probably eat a stone before you'd eat something bitter. And obviously you can train children. Just think of yourself the first time you tried gorgonzola and said, oh, how can anybody possibly be eating this for fun? You know, but, and we're now being confronted by an industry that is artificially enhancing the tastes and the odours to make us eat more. And by putting fat in, we like it again. You know. What our children eat affects our behaviour as an adult. We use food to reward children. We use food to silence children. We deprive food as a punishment. There's food advertising on TV. Children like highly palatable, highly fat, high sugar, high salt foods. And importantly, some parents don't persist in trying to teach the children to, that's an important point. They don't teach them to eat properly. Parents will also say there are safety issues, that the children, they don't want them going out running in the street because they might get run over, or they might get beat up, or it depends where you live. Schools will say, we can't afford to take them to gym, we can't afford to take them out to the playing fields, and the kids stay at home and do computer games. We've got warm houses. If you're not in a warm environment, you use a lot of energy to keep yourself warm. You blow off a lot of calories if you live in a cold environment. These are all the kind of things you know are right in your face as problems. But I just talk for a minute as an exemplar. Take the case of a bus driver. If you're a bus driver, you're up at 5 in the morning, you go and you sit and you're behind on a bus, and it's stressful, and you drive till 9:30, you get off the bus, you go and have bacon, eggs and beans, 2 toasts and tea with your mates. You go on the bus again till 4 o'clock, and you go and have a couple of pints. Then you go home. Your wife, who's not well off either, puts a pizza in the microwave. Then you both sit down and watch TV. If you say, listen, Donald, you're going to have to change your lifestyle. It's very hard for Donald to change his lifestyle. Donald say, it means not going out with my mates. It means changing my life. I can't afford to eat the kind of food you're talking about. And when will I go to a gym? I use all my overtime that I can get. So it's very hard for a lot of people to change their environment. Changing environment is probably quite a nice middle-class thing to be able to do. And so what are the issues? We can't become a police state in relation to food and exercise, or maybe we can, but, you know. You would need to have something like the Hitler Youth without the ideology. How could you persuade persuade everyone to come out and exercise and think healthily. So what kind of... These are the questions that I hope folk will give me answers to. What public health initiatives can we put in place? With the costs of pensions, is the government really committed to keeping us alive? And the health of the poor is probably not a middle-class concern now. That's very important, I think, because 100 years ago, if you had worked in a factory, you said, I don't want the workers getting TB because I can get it. It's infectious. There was public concern about health because diseases were infectious. You don't have to worry about somebody else being fat because that's their problem. It's not infectious. Changing food habits is not going to be as easy as changing smoking or drinking alcohol. The food industry is a powerful lobby. And as I said, does society really want to change? The sort of options are quite painful for a lot of us. So what are the possible solutions? Well, this is the Orwellian solution. The Orwellian solution is that we take drugs, that the pharmaceutical industry will come up with compounds that we can take. So if you want the Orwellian solution, it's going to be there because Glaxo, etc., will be there, and I'm sure it's a perfectly reasonable thing for them to be thinking about. Now, societal solutions. Here are the more painful and long-term and costly things. Education, obviously. Identify people at risk. Put pressure on advertising companies. Put pressure on the food industry. Put pressure on schools in terms of not only the food they provide, but the exercise opportunities they provide. But one of my friends thinks that schools should be made to teach cooking as well. That she says that lots of young women now, and young men for that matter, don't know how to cook. They just, because their mum doesn't cook in a sensible way, and they don't know. And so there may be a case for trying to teach these kind of things in schools again. Create incentives for employers to change canteen food, install a gym, reduce overtime, vary work roles. Jamie Oliver's a great role model in many ways, and maybe use people like David Beckham, sort of role models for kids. Now, this is hugely difficult because it's going to be very costly. And it's going to be very long-term. But California, a couple of weeks ago, decided that they were going to tackle it. California is leading the way. And the man has his problems, and the man has... But will we all follow this? This is... I think is probably the long-term solution, but heaven knows how easy it's going to be. Thank you.